Make it stick. The Science of Successful Learning by Peter C. Brown, Henry L. Roediger III, and Mark A. McDaniel is one of the most influential books on how people truly learn effectively. It is based on decades of cognitive psychology research and corrects many popular myths about studying and memory. I am presenting here complete chapter-wise summary for you. Chapter 1. This opening chapter challenges our most common but false beliefs about learning. It shows that many methods students use like rereading, highlighting or cramming create a feeling of learning but not real retention. The authors argue that true learning is deeper, slower, and harder, but it sticks longer. The illusion of mastery. When we reread notes or textbooks, the material starts to feel familiar. This familiarity tricks the brain into believing, I know this. In truth, the brain is only recognizing patterns, not forming strong recall pathways. This is called illusion of mastery, knowing the material only when you see it, not when you must recall it. Rereading and highlighting are comforting but not effective. The power of retrieval. Instead of re exposing yourself to the same material, try recalling it. When you try to remember something and struggle a bit, your brain strengthens the memory. Each time you retrieve information, the neural pathway becomes more efficient. This is a retrieval practice. For example, a student who self tests after reading a chapter will remember more than one who rereads the chapter 3 times. Struggle is good, it signals real learning. Learning that feels easy usually means you are just reprocessing, not mastering. When learning feels hard, your brain is engaging in effortful retrieval, which leads to stronger encoding. So the struggle is not a sign of weakness, but a sign that learning is taking place. Learning is deeper and more durable when it is effortful. The problem of massive practice. Cramming. Cramming before exams works temporarily, but fails long term. You might perform well the next day, but forget the material within a week. And this is because cramming stores information in short term memory, not long term memory. Real learning requires spacing, revisiting material over time after forgetting has begun. The misleading feeling of progress. Fast learning often gives a false sense of progress. When you read something several times and it flows smoothly, you feel you have learned it. But real mastery means being able to recall, explain, and apply knowledge independently. The authors use the phrase fluency illusion. Fluency in reading isn't equal to fluency in knowledge. Learning that lasts feels uneasy. The best learning methods, retrieval, spacing, interleaving, feel slow and frustrating. but those methods force the brain to consolidate knowledge. The key area is the easier is the easier the learning feels, the less likely it is to stick. Key research examples. In experiments, students who studied by testing themselves remembered more after a week than those who reread the same material several times. Another study found that learners who mixed topics during practice learned more deeply than those who practiced one topic at a time. The results were clear. Quote, what we think helps learning often hurts it, and what we think hurts learning actually helps it. Core principles of Chapter 1. Number 1. Retrieval practice beats rereading. Effortful learning builds lasting memory. Cramming creates illusion, not mastery. Ease and fluency are deceptive. Learning that feels slow actually sticks better. Key quote from Chapter 1. Learning is deeper and more durable when it's effortful. Learning that's easy is like writing in sand, here today and gone tomorrow. End of Chapter 1. Chapter 2. Main area. The most effective way to learn is not through reviewing or rereading, but through retrieving information from memory. Every time you try to recall knowledge, even when you struggle, you strengthen memory traces and improve long term retention. Learning is strengthened by retrieval. If you want to learn, test yourself. Detailed summary. Retrieval practice builds stronger memory. Each time you pull information from memory, you recognize, reorganize, and reinforce it. Retrieval makes the brain reconstruct the neural pathway, strengthening it for future recall. Simply put, remembering something is learning. Example. Students who take a test after reading a passage remember 50% more after a week than those who reread it several times. Forgetting is not failure. Forgetting is a natural part of learning. It makes later retrieval stronger. When you struggle to recall something and then successfully retrieve it, the memory becomes more durable. The harder it is to recall, as long as you eventually succeed, the more it sticks. Effortful retrieval makes memory playable again, strengthening the connections. Testing isn't just for assessment, it's for learning. Many students and teachers see tests as tools for grading, but research shows testing is a learning tool, not just a measurement. Practice tests, self quizzes, and flashcards are forms of retrieval practice. Tests help both solidify knowledge and reveal gaps. Testing interrupts forgetting. Feedback enhances retrieval. Retrieval works best when followed by feedback, knowing what you got right or wrong. Without feedback, you may reinforce errors. Immediate feedback corrects misconceptions before they harden into false memories. After a self quiz, check answers right away and note what was wrong. This active correction improves future recall. Retrieval makes learning transferable. When you recall knowledge in varied contexts, your brain builds flexible connections. This helps you apply knowledge in new situations, the mark of true understanding. Retrieval transforms static knowledge, facts you can recite, into usable knowledge, skills you can apply. Repeated retrieval beats repeated review. Repeated testing, even if done less often, outperforms repeated reading or highlighting. Example: Group A rereads material 4 times. Group B reads once, then takes 3 tests. After a week, Group B remembers far more, even though they studied less. Retrieval changes the brain. Memory is not like storing data in a computer, it's reconstructed each time it's recalled. Retrieval updates the network of associations around that knowledge, making it richer and more connected. Each recall strengthens both the memory itself and its accessibility. Core principles introduced in the chapter 2. Number 1. Testing is equal to learning. Every retrieval strengthens memory. Number 2. Struggle is good. The harder the recall, the stronger the retention. Number 3. Feedback matters. Immediate correction prevents wrong learning. Number 4. Forgetting is functional. Letting time pass before retrieval increases its power. Number 5. Repeated retrieval is more beneficial than repeated reading. End of chapter 2. Chapter 3. Chapter 3 introduces one of the most powerful and surprising findings in learning science: interleaved and varied practice. Main idea: people often believe that practicing one skill repeatedly until it feels smooth, called blocked practice, is the best way to learn. But but research shows that mixing different topics or problems together during practice, called interleaving, produces much deeper and longer lasting learning. In short, don't practice one thing until you are perfect. Mix things up. Detailed summary of the chapter. The trap of blocked practice. Blocked practice means repeating the same type of problem or skill again and again. For example, A, 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 A. It feels productive because you get faster and more fluent in short term. However, that fluency is temporary. It relies on short term memory. When tested later, learners who practiced in blocks perform much worse than those who practiced in mixed or varied ways. Massed practice gives you the illusion of mastery, not the reality. Example: students practicing the same kind of math problem 20 times in a row get good results during practice but forget most of it within a week. The power of interleaved practice. Interleaved practice means mixing different kinds of problems or topics. For example, A, B, C, A, C, B, as opposed to A in blocked practice. This forces the learner to identify the type of problem before solving it, not just to repeat a memorized process. It strengthens the brain's ability to differentiate between concepts and choose the right strategy. Interleaving builds the ability to discriminate, to know what kind of problem you are facing and which solution to apply. Varied practice builds flexibility. When you vary the conditions of practice using different examples, problems, or settings, you develop adaptive understanding. You are not just memorizing, you are learning how to apply knowledge in different contexts. This is crucial for real world problem solving. For example, baseball players who practiced with randomly pitched fastballs, curveballs, and sliders performed better in actual games than players who practiced one pitch type at a time. Mixing feels hard, but that's why it works. Interleaved practice feels confusing and slower. You don't feel like you are improving much, but this difficulty is desirable. It makes learning stick. The brain must work harder to recall and decide what to do, reinforcing deeper learning. When learning feels easy, you are probably not learning deeply. Interleaving builds pattern recognition. Real experts, real expertise depends on the ability to recognize patterns and apply principles correctly. Interleaved and varied practice develops this ability because you are constantly switching and comparing. You learn when and why to use a method, not just how to use it. Example: geometry students who practiced mixed problem sets, area, volume, perimeter, etc., outperformed those who practiced each type separately, even though the mixed group felt less confident. The key is contextual interference. When different topics or skills or mix it, the interference between them slows initial performance. But this contextual interference leads to stronger encoding and better retrieval later. In other words, we can say interference strengthens learning. It forces your brain to think. Core principles introduced in the chapter. Number 1. Blocked practice gives fluency illusion. Feels good, fades fast. Number 2. Interleaved practice gives real learning. Feels harder, lasts longer. Number 3. Varied practice builds transfer. Learners can apply skills in new contexts. Number 4. Confusion and struggle are part of effective learning. Number 5. Recognizing patterns is better than memorizing routines. In short, do not do the same thing over and over. Mix it up, challenge your brain, and you will learn more deeply and remember longer. Mixing up your practice may feel less productive, but it's far more effective. The more you vary your practice, the better you learn to apply your knowledge flexibly. Mastery comes not from rote repetition, but from interleaved, effortful practice. End of chapter 3. This is also the end of part 1 of the audiobook. Make it stick, the science of successful learning. We will meet in part 2, starting from chapter 4. Till then, have a nice time. Thank you for listening.